In this short video, we're going to show how an F-22 in an aircraft simulation software can be fully made autonomous by using software from TinMan. That's TinMan real-time to receive the sensor data, to map it, fuse it, and to send it on to AI Builder to make decisions and then map those to aircraft commands. Okay, here we are sitting on the runway. This time around we're going to just sit in the cockpit while the system takes off. I'm also going to be toggling around. In the background here you can see AI Builder. I'm within a system module right now. This is the master state awareness module, and I've integrated some text update messages that the system will provide us as visual cues as to the state that it's in. In addition, I've implemented a master engage switch that I can turn on and off. Once I turn it on, the AI system will take over. It's listening right now, and there's some color coding for the various stages. If I go out to the system level, we're in this module here, the state awareness module. There's a takeoff module, and that's this one here, and a takeoff management in the air module. This is the pitch management module. This is the roll management module, and then I have a pilot analysis module for the physiological data input. These are the output commands. Alright, so without further ado, let's go ahead and engage the system. It's listening right now, so I'm just going to press this button and we'll take off. Flaps down a notch, flaps down a notch, flaps down a notch. Landing gear up, retract flaps. Go out. Level flight, reducing to cruise speed. Okay, that's pretty much it. You heard the verbal cues. Those were pre-recorded messages that I've asked the AI system to provide at the various stages of the state awareness phase changes. And we're just going to continue to fly at this level for as long as I want to, and I'm going to go ahead and stop the video here. That was the inside the cockpit view. We have three applications running. We have X-Plane 10 with an F-22 sitting on the runway ready for takeoff. We have TinMan run real-time, which has a display set up with a number of gauges that will be receiving sensor data. We have a sensor data template that we've imported for X-Plane 10 that reads the up to 8 to 12 values for any of the 133 sensors on board. And then we have UDP command strings, any of the 1071 command strings that can be sent to the aircraft. And so we'll be using that UDP data source and that UDP data target. We'll be displaying the data through select gauges that we've placed on the screen, gauges and charts, and we'll be relaying the commands from AI Builder through these white rectangles over here. So if you just look at the vertical line of rectangles for managing flaps and trim up and throttle and gear, landing gear, and rudder. You'll see these blink as commands are delivered to X-Plane 10. We have the simulator off at the moment so that we can talk without the plane operating. The third application is TinMan AI Builder. We have 4 modules that we've created and put on the screen. The system inputs that will be received from real-time, well actually from X-Plane via real-time, are just a select set just to do a minimal liftoff to about level flight at 15,000 feet. And then we have commands and decisions that are made by AI Builder for managing flaps, brake, throttle, landing gear, and then orientation of the aircraft as it moves through the various stages of this flight plan. The flight plan itself is to lift off. It's actually to lower the flaps, to increase speed and thrust to a certain speed, to then pull up, get your liftoff pitch, maintain level flight, bring the gear up, bring the flaps up, increase altitude, and then have level flight at about 10,000 feet. I'm just clicking on the various components here. I won't walk you through the logic within these. What I would urge you to recognize is the simplicity of each of these modules. This in particular is pitch management, and there are 3 different phases, actually 4 different phases of the flight. One is on the runway, that's a level pitch, and then there's the liftoff pitch, which we're just going to set to about 20, and then there's climbing pitch. After you get to 1,000 feet, you'll climb to actually 10,000. This should be 10,000. We'll set the pitch to 10, and then ultimately we'll have level flight at above that desired altitude. What we're looking at here is we got a single derivative model of managing the change in pitch and how the aircraft is managed as it moves through those various phases. These right here, these graphical controls, are to simplify the display as you build your logic, and this helps me in particular in designing the demonstration here. And we can consolidate those enclosed components here so that the screen gets even more manageable. So you can modularize the visual nature of your logic if you want to simplify the display. And then here is role management, and again a single derivative model for managing jitter as you move through the different phases, or managing roll so it's not choppy. And so that is the third application. Okay, so we're ready for liftoff. When I click the radar symbols within TinMan Real-Time, what that will do is it will allow the receipt of all of the data being sent by X-Plane through UDP into real-time for visualization, and then also for relay to TinMan AI Builder, and that will then cycle these decision modules to then relay back these decisions on how to manage the aircraft to TinMan Real-Time. You'll see these white rectangles blink as commands are executed and then sent and delivered directly to X-Plane. So what I'm going to do is put X-Plane on top. We'll just watch TinMan Real-Time, and what we'll probably do is do this a couple times so that you can see each of the applications operate entirely. Alright, so let's go ahead and get started. I'm going to click Go, and you'll see the flaps go down 2 notches, and you can watch the commands get executed here. This one here is signifying full flaps down. Okay, they're achieved desired thrust. So as we get to about 1,000 feet, the gear should come up, and you can watch the various commands being sent. The gears are set up. I'm not touching anything on the display. Turn down the volume here a little bit. And as soon as we get to about 10,000 feet, we should see the aircraft. The pitch drop a little bit. Right now we're at about 18, 19 degrees. You can see that it's starting to level off. I think it's 10,000 feet, we will drop down to a 2 degree, about a 2 degree pitch. There we are, we're dropping now. There's the pitch we're looking at. We're at level flight. And now you can see the various commands that are being sent from TinMan AI Builder to manage this level flight. This will just continue on. Right now we haven't really done much with the next stages, but we could very well set a heading and then can change and follow that heading. We could set various waypoints and also bring the aircraft to a landing. And that's one of the demos that I'm sure we'll put out real soon. But let's go over to, while this is running, let's just go into AI Builder, and you can see that AI Builder is receiving this data dynamically. And if I go into, and it's managing the various actions for the aircraft, you can see the zeros and the ones blinking for pitch up, pitch down, trim right, trim down. So I can very confidently allow TinMan AI Builder to operate that aircraft. Let me just jump in here. You can see in the roll management, this is essentially managing the level flight, the roll, trim of the aircraft, trim left, trim right. You can see a little bit of blinking on the 1 and the 0 here. That's setting the back of command to real time, where you can see trim left and trim right. Those are the commands that are being delivered. If we drop down this command, you can see the actual commands as they're being sent to the aircraft. And this may be too frequent or not frequent enough for a final system, but at least the aircraft is being managed near perfectly. And let's go back. There's the aircraft, and I'm going to stop here, and perhaps we dig in with various stages.